And we're back. So the 3U people, we've spent lots of time, a couple days working with rational expressions now. Uh, so our strategy for simplifying these rational expressions is to factor. You guys should be able to factor the top. It's a simple trinomial. And after Friday, we should all be able to factor the bottom. In this question, I have provided space on the side for you to factor the bottom using the Australian method. So we will just move a bit faster through the factoring for the 3 people here. We've done a lot. You guys did it in grade 10. The top is just a simple trinomial. What adds to 7 multiplies to 12, 3 and 4. On the bottom, we do need the Australian method, so I'm going to do this to the side. 2x squared plus 11x plus 15. So it's 2x, it's 2x, it's 2 on the bottom, and everything's positive. And what adds to 11 and multiplies to 2 times 15 is 30. And those two numbers are 5 and 6. Again, we should be able to move a bit faster through our factoring. I reviewed this method with you guys on Friday, gave you an opportunity to practice a lot. And then you divide what you can. 2x plus 5, can't do anything with that. You can take a 2 from 2x plus 6. You're left with x plus 3 all over 2. And then you divide out the 2's. So just to be clear, the 3U people, we should be comfortable doing this at this point. All right, now I did mention that intermediate step, not necessary. If you can just visualize what's going to happen, you can go right there. But now we factor the bottom. 2x plus 5 times x plus 3. And then from several days ago, we talked about simplifying these rational expressions. If you have a similar factor on the top and bottom, they divide to 1, and you can simplify things a little bit. So we get x plus 4 over 2x plus 5. So those two expressions are algebraically equivalent in every way except, and then you guys looked at the bottom and asked what makes the bottom 0. So I think everybody could probably recognize that x can't be equal to negative 3. But what about 2x plus 5? What makes that equal to 0? So I'm going to do a bit of a deeper dive into the restrictions here. We're going to add to that in a second. So can you guys do this with me? So where did the x equals negative 3 come from? So what we're saying is that x plus 3 cannot be equal to 0, because then you'd be dividing by 0, and that's bad. And if you were back in grade 9 and you were solving this little dinky little equation, x plus 3 equals 0, what you would do is you would just move the 3 to the other side. And that's why we say x can't be equal to negative 3. It's because we're solving that little dinky little equation, x plus 3 equals 0. That's where that one comes from. For our second restriction, we ask, okay, what makes 2x plus 5 equal to 0? So we're going to say 2x plus 5 can't equal to 0, because then we'd be divided by 0. What value of x makes that 0? So just like in grade 9, do a little two-step solving. So bring over the minus 5. Bring over the 5 becomes negative. So 2x can't be equal to minus 5. And then divide both sides by 2. You get the second restriction on x. X can't be equal to negative 5 over 2, or negative 2.5. That's our second restriction here. I'm going to add also that x can't equal to negative 5 over 2. But now we've shown where that comes from. For this little mini note, I'm going to show this work. But hopefully what you guys get to in the wild is that you can just recognize, okay, yes, if x is negative 2.5, this will make that bracket 0, and you can just state your restrictions. Just like we did for x equals minus 3. So absolutely nothing new here, because you guys already knew how to simplify rational expressions. We're just mixing in a complex trinomial, and we're stating restrictions, but when the bracket has something in front of the x, a little bit more thought's required for the restrictions. You guys okay with that? So we're just tying in all the skills we already have. So we're just going to do one more. That was it. That was basically the lesson. So a few days ago, you guys learned how to multiply, divide rational expressions. We're now going to mix in other types of factoring too. Now we don't need, I'm going to do this one with you guys. We don't need the Australian method for this one, because this is these are all special patterns in here. So let's start by factoring. So the top, what adds to 6 multiplies to 9, 3 and 3. So that would be x plus 3 squared. On the bottom, 4x squared minus 4x plus 1. That is a perfect square trinomial. So we've done enough of these. I think we'll just go right to the factored form. 2x minus 1 squared. If you want to go in the margin and do that as an Australian method, you get the same answer. And then what do we get on the other side? X squared minus 9, that's a difference of squares. So you guys should be able to do x plus 3, x minus 3. And on the bottom, that's another difference of squares. So 2x plus 1 and 2x minus 1. So absolutely nothing new there. That's all grade 10 factoring stuff. And we've reviewed all those methods. So the factoring should not be the hard part of our day at this point. If it is, you got to practice more, come get help. Before we do all the slashing, we got to rewrite that as a multiplication. So invert and multiply, just like dividing fractions. And now we can hopefully do a lot of canceling. I think a lot of canceling happens here. So we've got x plus 3 squared on top and an x plus 3 on the bottom. We can divide out one of those, like so. And then the 2x minus 1 on top, yeah, we can do another slash there. That only divides out with one of them on the bottom. I think that's all the canceling we can do. And so we are left with x plus 3 times 2x plus 1. It's a weird x. Over 2x minus 1 times x minus 3. That division is equal to that. They are algebraically equivalent in every way except. So there are 4 restrictions on x for you guys to find. I'm actually just going to pause the recording and give you guys a second to see if you can figure out what the 4 are while I pass around the next thing for the 3U people. See if you can figure out what the 4 restrictions are. That's a hint. There are 4. All right, 3U people, we're going to tie a bow on this. So we are looking around the entire question. Every step of the way, we're asking what can make the bottom 0. So I see from the original question, we have a 2x minus 1 and a 2x plus 1 that can make the bottom 0. For the second line here, I can see there's x plus 3 and x minus 3 to make the bottom 0. There's 4 different brackets in the bottom there that can give a restriction. I'm going to show a whole bunch of extra work here that you don't need to show, but maybe write down if you need to feel comfortable. So what makes 2x minus 1 equal to 0? Well, you bring over the 1, makes it positive, and then you divide by 2. There's kind of a pattern here. So from that bracket, x can't be 1 over 2. And then from the 2x plus 1 bracket, can't be 0. You bring over the 1, it becomes negative. And then you divide by 2. You get a second restriction. X can't be negative 1 over 2. The next few you guys should be comfortable with from earlier classes. Bring over the plus 3 becomes negative. X can't be negative 3 from that bracket. And then finally, x minus 3 can't be equal to 0. I'm showing all this work. All this work is not necessary. It's just to show you where our restrictions come from. Ideally, you guys can just pick these off by just looking at the factors. So we have our 4 restrictions. I'm just going to list them. So x can't be equal to 3 or minus 3. If you guys are okay, we can write that concisely as plus or minus 3. And x also can't equal plus or minus a half. But I showed you guys where those restrictions come from. I'll just write this on the sideboard, and then you guys can go start using this in your note. So let's say you 3 people have factored the bottom, and you have a bracket like this. If you want to get the restriction, you bring the b over, it changes sign, and then you divide by a. That's always going to work. So like this one, bring over the minus 1, positive 1, divide by 2. Bring over this, negative 1, divide by 2. That shortcut always works, but you can show that work if you need to. Okay, so you 3 people are now equipped to do any multiplying, dividing, rational expressions question. And so that task you guys have gives you a lot of practice.